Hello everyone. So far in our Python journey, we have learned the fundamentals of programming, including variables, data types, operators, conditional statements, loops, functions, strings, lists, tuples, dictionaries, and sets. Also arrays. These concepts helps us to solve problems by writing step-by-step instruction. However, as a program become larger and more complex, managing the code using only functions and variables become difficult. To overcome this challenge, Python provides object-oriented programming, that is OOP, a programming paradigm that organizes code into objects and classes. OOPS makes programs more structured, reusable, secure, and easier to maintain. In real world, everything around us can be considered as an object. A student, a car, a mobile phone, a bank account, or an employee. Each object has properties, that is attributes, and behaviors, that is methods. Similarly, in Python, we can create objects that stores and performs action. In this lecture, we will understand the fundamental concepts of OOPs, such as class, attribute, objects, method, construction, and init, and the self keyword. We will also learn how to create object, access their attributes, call methods, and modify object data using practical example. By this end of the lecture, you will able to learn and sorry you will able to understand the need for object oriented programming, create classes and objects in Python, define and initialize object attributes using constructor, you use the self keyword efficiently, write methods inside a class, access and modify object attributes, build simple real world applications using OOPS concept. Real life analogy. To design a blueprint of a car is called class. Every car has a manufactured by the blueprint is called an object. Then etc etc. This is the exact how object oriented programming works in Python. Let's begin our journey into object oriented programming and learn how to build powerful, reusable, and real world Python applications. So let us start with OOPS. Object oriented programming was initially introduced at MIT in 1950s and fraction sorry gained attraction in the 1970s. During the 1980s, Journey Strostrup incorporated OOPS principle into the C language. Creating C++, this language marked the first instance of a widely used and commercially successful object-oriented programming language. In 1990s, James Gosling of Sun Microsystems developed Java, a simplified version of C++. It found extensive application in internet-based applications. As the internet gained widespread popularity, Python created by Guido van Rossum in 1989 had object-oriented programming capabilities by 1990. So, what is object oriented programming? It is a programming paradigm based on the concept of objects, which may contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. Any object oriented programming, that is OOPS language, should incorporate the following fundamental concepts. Encapsulation, the capability to model real world entities with their characteristics, attributes, and behavior, that is methods, while concealing irrelevant details. Second, inheritance, the capability to create new classes, that is subclasses based on existing classes, inheriting their attributes and methods. Polymorphism, the ability of an object to modify its behavior based on the type of data it is processing. Python, along with all languages, Java, C++, C, and Smalltalk, supports the fundamental concepts of object-oriented programming, making it versatile OOPS language. Then object-oriented programming languages are diverse, but the most popular ones are class-based, meaning that objects are instances of classes, which are so determine their types. The concept of a class. In object-oriented programming, we use classes to represent real-world things, scenarios. We create objects based on those classes. Definition. A class is a blueprint or a design that defines the variable and the methods common to all objects of a certain kind. The data stored in its variable are known as attributes or fields. The code that can access the data to given the necessary output is called method or a function. So we understood that a class is used to associate code with the data that is operates on. Using a the class reduces the complexity as the code increases. An object is an instance of a class, and an instance refers to a specific object created from a particular class. The process of creating an object from a class is known as instantiation. Example: suppose we need to build a class car for Honda company. The variable name, color are the attributes of the car. A method getSpeed is defined inside the class car, which does some manipulation of the attribute and returns the output. Honda City is the instance object of the class car. So let me give a sample code. That is, let me move to the ideally Python and let me open the code, that is PRO class car def init self comma name comma color. Self dot name is equal to name. Then self dot color is equal to color. Then def get speed self print stop speed of plus self dot name plus is 150 kilometer per hour. So after that, we have to give the Honda, creating the instance called Honda City. So Honda City is equal to car Honda City Honda City dot get speed. So let us run the code. You can see the output has been produced here. The top speed of Honda City is 150 kilometer per hour. So next, proceed understanding OOPS concept is the next topic. That is procedural programming, emphasis on procedures to be implemented, whereas object oriented programming approach views a problem in terms of objects or entities involved rather than the procedure. Therefore, objects are a key to understand the object oriented programming. The concept of object. An object is a software bundle of variables and related models. We can look around and find many examples of real world objects such as mobile phone, car, ceiling fan, clock, etc. All these real world objects share two characteristics, that is state and behavior. For example, mobile have state, that is model name, color, battery saver, switched off or switched on. And behavior is call, ringing, playing music, recording video, software objects imitate real world objects. Thus they too have state and behavior. The software object maintains its states in one or more variable represented by its data and implements its behavior with function, often called as methods. These variables are conveniently known as instance variable because they contain the state of a particular object called instance. And these methods are conveniently known as instant methods because they can change the state of a particular object. Therefore, in object oriented programming, an object represents an entity that can store data and has its interface with outside world through methods. So a class can also be described as a representation of characteristics and behavior of same category or family of objects. Hence, an object, that is Honda City discussed in the previous question, can be considered as the instance of a class called car. So let me move to the next topic, that is encapsulation. Encapsulation is one of the most fundamental concepts of object oriented programming. It describes the idea of bundling data and methods that work on data within one unit by restricting access to some of the object's component, that is variable and methods. A class is an example of encapsulation as it binds together the data and associated functions under one unit. Encapsulation is equal to abstraction plus information hiding. Advantages: it can prevent the accidental modification or misuse of data by outside entity. It provides programmers with better control over flow of data in their programs. Abstraction is used as a technique to identify all essential characteristics, behavior of an object, and to omit those aspects which are unimportant. Information hiding means hiding all the unnecessary information like implementation details from outside entities. A class group its member into three sections as private, protected, and public. The private protected members remain hidden from outside world. That is, a class enforces data hiding. The outside world is given only the essential and necessary information through public member. Rest of the things remain hidden, which is nothing but abstraction. So next, imagine a car factory. Before production, you need a blueprint showing the car structure, brand, model, color, and engine type. The blueprint itself is not a car. In Python, a class works in the same way. It is a blueprint that defines the structure and attributes of the objects. So, what are objects? Think about the cars produced by the factory. Even if two cars are the same model, like Toyota Corolla, each car is unique. In Python, these cars are called objects or instance of a class. Each object has its own copy of attributes. So let's move to next topic, that is creating a class in a Python. Let's define our blueprint. So let me use Notepad for this. Here, creating a class in Python. So that can be created by class car, then pass. So this is the empty blueprint to make it useful, and we add attributes property that describes each car like brand, model and color. Attributes give each object its own identity even if the blueprint is the same. So next, that is defining attributes with init. In Python, we define attributes using the init method, which is automatically. Let me show in the defining attributes with init, which automatically called whenever a new object is created. This method is called the constructor. It is the method Python runs to construct, that is to make a setup a new object as soon as it is created. So let us see an example. Here class car, then def init self brand model comma color is given. Then self dot brand is equal to brand. Then self dot model is equal to model. Then self dot color is equal to color. Here, self refers to the specific object being created. Brand, model, and color are instance attributes, meaning each object gets its own copy. You never call init directly. Whenever you create a new car object, Python automatically calls init for you, passing along the values you provide and assigning them to that object's attribute. With this, our blueprint is complete. Every car produced will automatically have a brand, model, and color. Each car we produce is an instance of the car class with its own brand, model, and color. In the next module, we will see how to create objects and explore how they behave independently. So now that you have learned what a class is and what attributes are, let's define a blueprint for a school. We will create a school student class. The class should have the following attributes: name, roll number, then class name. The instance are already created for you in the provided code. Means you have to define student var. Let me move to the ideally Python. Let us open the script mode, that is class student, then def underscore init, then underscore, then self, comma, name, comma, roll number, comma, class, underscore, name, then parenthesis close. Then here, self dot name is equal to name. Then self dot roll number is equal to roll number. Then self dot class name is equal to class name. Then in the function call, we have to create the student object, that is name is equal to input. Then roll number is equal to int of input of, then class name is equal to input. Then student is equal to student name, comma, roll number, comma, class name. Then print student details. Then print name, comma, student dot name. Then print roll number, comma, student dot roll number, then parenthesis close. Then the last print statement, that is print class, comma, student dot name. So F5. Let us run this. So let me run it. So see students, the output has been displayed correctly. So this is being helping for the object-oriented programming. Well, so we will be moving to the next concept, that is constructor. A constructor can be viewed as a specified method used by a class to perform tasks such as initializing of variables or any startup task that needs to be done when an instance of class should be created. In Python, the constructor is defined with a single name called init. Across all the classes, this method has to leading underscore and to trail underscore. A convention that helps prevent Python's default method names from conflicting with user-defined method names. When we create a class without a constructor, Python automatically creates a default constructor that does not do anything but initiates the object. Python does not support constructor overloading. If you try to overload the constructor, the last implementation will be executed each time. Any previous implementation will be overwritten by the last one. Look at the syntax of init self method. So let me give the syntax here. That is def init, then self, parenthesis close, then so in next line def self argument 1 comma argument 2, it goes on to argument n. So remember these two syntaxes every time. Note, observe that self argument always precedes the other arguments. So let us move to the next topic, that creating objects and accessing attributes. Creating objects and accessing attributes. Introduction. A class is only a blueprint or template. It defines what an object should look like, but it does not occupy memory or represent a real world entity. To make a class useful, we create objects, that is instance from it. Each object has its own data and attributes can be perform actions that are methods. Let me give a real life example. Class is car blueprint. Objects are Toyota, Honda, BMW cars. Each car has its own brand, model, and color, even though all are created from the same blueprint. Then, what is an object? An object is an instance of a class. When an object is created, memory is allocated for it. Attributes are initialized. Each object stores its own data independently. Syntax, that is, object name is equal to class name into that parenthesis we give argument. Example, class car def init self brand model color. Self dot brand is equal to brand. Self dot model is equal to model. Self dot color is equal to color. Creating objects. Car 1 is equal to car Honda, model is Corolla, then color is red. Then car 2 is equal to car of Honda, the model is Civic, and the color is blue. Here, car 1 and car 2 are different objects, but both belong to same class car. Each object has different attribute values. Second, creating multiple objects. A single class can create any number of objects. Here, the car variables are 3 and the different types of car is 3, but the class is only one, that is car. Each object has its own memory, its own attributes, independently data. Accessing objects attributes. After creating an object, we access its attributes using the dot operator. Syntax object underscore name dot attribute name. Example, print car1 dot brand name. Sorry, brand. Print car1 dot model. Print car dot color. Output will be the objects present in the variable carbon, that is Toyota is the brand, Corolla is the model, and color is red. Then same as for the car 2. How the dot operator works. The dot operator is used to access attributes methods. Accessing attributes. Carbon dot brand, carbon dot model, carbon dot color. Calling methods. Carbon dot start engine. Fifth one, complete example, class color. Diff init self comma brand comma model comma color. Self dot brand is equal to brand. Self dot model is equal to model. Self dot color is equal to color. Create objects. Car 1 is equal to, already you have seen that car 1 has the value Toyota Corolla and red. where car2 has the value car, Honda, Civic, blue. Access attribute print car1, print brand, car1 dot brand, print model, car1 dot model, print color, car1 dot color. Then give a print statement outside. Same for car2. Car2, then car2 dot brand, car2 dot model, then car2 dot color. So the output will be like this. Then key points to remember. A class is a blueprint. An object is an instance of a class. Objects are created. Use the class operator, constructor. Each object has its own copy of the attributes. Use the dot operator to access object attributes. Creating one object does not affect another object. Now create a class manager which contains the details of manager like name, department and salary. Take name, department and salary as inputs from the console. Print the results as shown in the example. So let us do the coding together in ideally Python. So students all open script mode and take the any example code and do the coding with me. Class manager def init self, comma, name, comma, department, comma, salary. Self dot name is equal to name. Self dot department is equal to department. Self dot salary is equal to salary. Let us give the name is equal to input, then department is equal to input, then salary, sorry, salary is equal to int of input, then emp is equal to, sorry, employee1 is equal to manager name, comma, department, comma, salary. Then print emp1 dot name, that is emp1 dot name, then then print, sorry, f imp underscore one dot department is to imp underscore one dot department, then print f imp underscore one dot salary such that imp one underscore one dot salary. F5. So this is our code in ideally Python. Let me see it. Rajesh accounts. So this is the code. The output is. So let us see another example. That is, write a program that defines a class employee and add a password, passkey. The steps are class employee is already defined in the program. Create an instance employee one of class employee. Take the name of the employee as the input string and assign it emp1 dot name. Set employee salary to 25,000. Print name, print salary. So let us start in the ideally Python. Class employee, then pass emp1 is equal to employee, then name is equal to input name, then emp1 underscore 1 dot name, sorry, name is equal to name, then emp1, sorry, emp underscore 1 dot salary is equal to 25,000. Then print, print emp underscore 1 dot name such that, comma, emp underscore one dot sorry underscore one dot name, then parenthesis close. Then in the next print statement, print emp underscore one dot salary is to quotation close, then comma, then emp underscore one dot salary. So let me run this code for you. So F5, then OK. Here name is Rajesh. Then the salary is the employee name is Rajesh and the emp salary is 25,000. So let me display the output in the interactive mode for you students. So this is the input for the program which I have given. So next, moving on to methods. So far, we have created class that hold data like brand, model, and color. But in the real world, objects does not store information. They also do things. In Python, these actions are represented using methods. In a class is a blueprint and an object is the real car. Then methods are what making that car to do something like pressing a button to start it. A method is a function defined inside a class that works with the class attributes and performs some operations using them. In Python, every method has a special first parameter called self, which refers to the object that called it. So let me give the syntax for that. So let me erase the whole thing. So, before that, let me give the Viva questions for you. First question, what is an object in Python? Second question, what is mean by an instance of a class? Third, how do you create an object? Fourth, can one class create multiple objects? Fifth, how do you access object attributes? Sixth, which operator is used to access attributes? Seventh, do different objects share the same attribute values? Eighth, what happens when an object is created? Ninth, what happens when see what is the difference between a class and an object? Why memory is allocated when an object is created? Then one line summary. A class is a blueprint, an object is a real instance of that blueprint, and the object attributes are accessed using the dot operator. So let me erase this Viva questions and give you the syntax of method. So class car is to then def init self comma brand comma model then parenthesis close then colon then self dot brand is equal to brand then self dot model is equal to model. So let me increase this font so you can be easy to identify. So let me move this. Def start engine self underscore then print f self dot brand then parenthesis close. Sorry, that is set bracket. Then here the set bracket is I again open, then self dot model, then again close is starting. So start engine is a method, a function inside the class. When we call the carbon start engine, Python automatically passes the carbon object as the value for self. So inside the method, self brand refers to carbon dot brand. Similarly, self dot model refers to the carbon model. Next, here is a point where I should give the importance. In Python, every method has a special first parameter called self, then which refers to object that it calls. So now let's move to the task, that is to write a program, that is after creating an object, we access its attributes using the dot operator. Syntax object underscore name dot attribute name. Example print carbon dot brand name. Sorry, brand. Print carbon dot model. Print car dot color. Output will be the objects present in the variable carbon. That is Toyota is the brand, Corolla is the model, and color is red. Then same as for the car too. How the dot operator works. The dot operator is used to access attributes methods. Accessing attributes. Carbon dot brand, carbon dot model, carbon dot color. Calling methods. Carbon dot start engine. Fifth one, complete example, class color. Diff init self comma brand comma model comma color. Self dot brand is equal to brand. Self dot model is equal to model. Self dot color is equal to color. Create objects. Car 1 is equal to already you have seen that car 1 has the value Toyota Corolla and red, where car 2 has the value car Honda Civic blue. Access attribute print car 1, print brand carbon dot brand, print model carbon dot model, print color carbon dot color, then give a print statement outside. Same for car 2, car 2 then car 2 dot brand car 2 dot model then car 2 dot color. So the output will be like this. Then key points to remember. A class is a blueprint. An object is an instance of a class. Objects are created. Use the class operator. Constructor. Each object has its own copy of the attributes. Use the dot operator to access object attributes. Creating one object does not affect another object. The student class is already defined and initialized with the attribute name and name and grade. A student object has been created and the method call is already provided. Your task is to define a method named display details inside the class. So let us move to the ideally Python. Let me do the programming. Class student, sorry, student in next line def init, then parenthesis open self comma name comma grade, then parenthesis close, then colon, then self dot name is equal to name, then self dot grade is equal to grade, then here comes the method def display details self colon, then print name, then comma self dot name, then parenthesis close, then again a print statement, then grade, then colon, self dot grade, then close. Then here I'm going to take the input, that is name is equal to input name, then grade is equal to input grade, then student 1 is equal to student parenthesis open name comma grade, then parenthesis close, then student 1 dot display, sorry, display details. So let me run this code. So let me give the name as Ashwath. Then grade is 10. So FA. So the output has been displayed. Let me run the code for you. So see students, the output has been displayed clearly in the interactive mode. So let me move to the next topic, that is understanding the self parameter. Self tells when we create many objects from the same class, each object should keep its own set of attributes. Self tells a Python, hey Python, this belongs to me, not to anyone else. Without self, Python could not work with objects data you are trying to use. Let's give the example in Notepad. Let me explain this in the ideally shell itself. So let's begin with here. Class.core, then def init self comma brand comma color. Then in next line self dot brand is equal to brand. Then self dot color is equal to color. Then def show details, then self, then print f. This car is a self dot color, then space, self dot brand, then quotes quotation close, then list is closed. So now let us create details of two cars. That is car 1 is equal to car Toyota, then comma red. Then car 2 is equal to car Horida, sorry, Honda, then color is blue. Then car 1 dot show details, car 2 dot show details. So let us run this code, that is F5. So the output has been displayed correctly in the interactive mode. So students, this is the self parameter usage. So let me give the practice questions. Before we conclude this lecture, here are some practice questions for you. Try to solve them on your own without referring to the notes. Then the questions are like what let me give it. Um, what is class? What is attribute? What are attributes? What is an object? What are methods? Why is self used in every instance method? How do you create an object in Python? How can methods modify object attributes? What is the difference between a method and a function? Does Python support true method overloading? Explain. Then what is the dot operator used for? Then programming questions. Write a Python program to create a student class with name, age. Create one object and display the details. Second, write a program to create a student class and add a method display to print the student's name and grade. So, seventh one, write a program to create a bank account class with account holder and balance. Add a method deposit to update the balance. So, Thank you so much for watching Lecture 6 Part 1 of our Python full course. In this lecture, we have learned the fundamentals of object-oriented programming in Python, which is one of the most important programming used in modern software development. We started by understanding the concepts of classes and objects, where a class acts as a blueprint and an object is an instance of that class. We learned how to create objects, initialize them using init function, then constructor and access object attributes using the dot operator. Next, we have explored methods in class and we discussed the importance of self parameter, how it refers to the current object and how methods used to access it. We also practiced Python handles method overloading using default arguments. Since Python does not support traditional method overloading like some other programming language. So make sure you practice all the examples and solve the practice questions to strengthen your understanding before moving on to the next lecture. If you found this lecture helpful, please like the video, share it with your friends, and subscribe to the channel so you don't miss the upcoming lectures. In the next lecture, we will continue with the Python journey by learning about the remaining three pillars, that is, inheritance, polymorphism, and abstraction with practical example. Until then, keep practicing, keep learning, and keep coding. Thank you, and I will see you in the next lecture. Happy coding!